Let's discuss question number 28 from test 7. This is from machine design. Okay, so what is given? A journal bearing 160 mm long, so length of the journal bearing is 160. The dia is 45 mm and the radial load is 8000 Newton. The shaft speed is 160 rpm and the oil used is SAE 60 25 degrees inlet temperature. The clearance ratio is either diameter by diameter clearance or radius by radius clearance. So let's write radius by radius clearance is 600. And so what is asked is power loss. Take mu r by C as 12. So remember that mu r by C, he has asked us to take 12. He has not given mu, so directly from this we need to calculate mu. So r by C is 600. So let's write 600 r by C, and that is 12. So mu is coefficient of friction is 1200 by 600. So that comes 0.02. So mu is basically the average friction coefficient. So mu is your average friction coefficient, which we got. Now in a journal bearing, when you have something like this, a shaft in a shell, and it carries radial load, can be anything. Let's draw it vertically, a load of 6000 Newton. So now, I have not drawn the picture correctly. Let's draw it correctly. Okay, so as it rotates, there is a converging wedge which forms, and there's a pressure buildup in this region. So the load is like this, and we have the average friction coefficient. So it's just you're replacing this with a dry friction, and you know the load and you know the friction coefficient here. So the friction is mu into W. So this is the friction. Now force into velocity is the power. Now friction force into velocity is the power spent against friction, or power lost due to friction. So this is the friction force, average friction force. The idea of getting a single mu value is replacing this entire hydrodynamic principle with just a single block, and basically mu W represents a dry friction synonymous of this part. So mu VW. So we know mu 0.02, W is 6000 newtons. V is velocity, surface velocity, it's pi d n by 60. So I know the diameter, which is 45, and the speed, which is 160 rpm. So everything is known, 60,000, and so if I just substitute that in the power loss, so let's substitute 0.02 into 6000. Sorry about that, load is 8000, so 8000 into pi into diameter 45 into 160 by 60. So this value, so pi dn, it's 45 mm, so 10 power minus 3, and so this value comes out to be 60.32 joules per second as a unit of power. So the answer to this is with the help of calculator. So the answer for this is B. This is a fairly straightforward problem. Just you should know how to calculate the power, and then rest is all substitution. Thank you.